part of that is yes, signing up for the Khan Academy is actually part of your grade. Good. You need to do it the other way, or else you won't be able to get into it when we go down to the computer lab here. Because you cannot use Facebook here. That's why I said on the directions, set up a Khan Academy account, not sign in through your Facebook. Yes. Yeah, any of those ones that you did underneath Algebra 2, if you did any of them, then you got extra credit. Everybody else found them. Did you type it into the search bar at the top? There's a search bar and you type in and then they start popping up. Because you weren't supposed to graph polynomials. That wasn't under your name. So today we are going to we're going to section 4.1 now, because I didn't like how they did it. So we're doing 4.1 now. Graphing quadratic functions in standard form. And I have a MySpace. I know. MySpace is complicated. But they made a lot of money off MySpace. You know, Miss Small, you guys, her nephew actually gave him the money to start that. So he made millions and millions of dollars off of MySpace. So, no. Okay. Our goal is to graph quadratic functions. Exciting and new. So, gentlemen at the table back here, and Rebecca, you guys turning in your homework? So you're not failing at midterm? Why? Because you're talking about MySpace instead of working? I'm not going to go back because of that. Okay, next. Why? So we can model sports revenue as an example 5. I did not do example 5, and it is an example, so I would appreciate it if you would look at example 5 in your book tonight when you're doing your homework, so you can see. And I was kind enough not to give you any story problems today. Yes, honey. No, you don't have to put y on your reflector. Why I put this up here is because some people are like, why are we ever going to use this? So y is just some examples of people and type of jobs that you would use it in. Because then you guys are always like, why? I don't know, maybe if you become a sports revenue person, then you would do it, right? And if you really want to know, on my door, if you haven't noticed, is a big sign that says, when are we ever going to use this? It has a whole bunch of jobs and things lined up. So, not for a while. Okay, graph the following. Okay, we can do a couple different things. We can make a table, right? But what form is this in? Anybody? It's very good. It's not intercept, so that means it's in what? Vertex form. Very good. How you can tell the difference if you really want to know, vertex form has a squared on it, intercept form doesn't. Okay, so if I'm in vertex form, what is my vertex? Huh? No, 1/2 is not vertex. What is my vertex? No. A vertex is a point, remember? X and Y. So what is it? No. What? 0, 0. Vertex form says y equals a times x minus h squared plus k, where my vertex is hk. And if there's nothing in h and k, guess what my point is? 0, 0. That should be in your notes from last. Yeah. Okay, good. Okay, so my vertex is at 0, 0. Nice. Okay. My line of symmetry is where? Nope. 0. Very good. X equals 0. Good. Okay. What does the 1/2 do? It is not slope. It changes what? Okay, is it going to open? Let's start with negative and positive. Is it going to open up or down? Y up. Because it's positive. Good. Okay, how do I normally get from one spot to my one point to my next point? I go over 1 and how far? 1 squared. I go over 2 and up how far? Over 3, up. Right, that's my parent function. Always looks like that, right? Okay, so what does the 1/2 in front have to do? What do I do with that? Multiply it by what? Take how far I normally go up and multiply by that number. Yes, dividing by 2 and multiplying by 1/2 is the same. Good. So what's 1 squared? Times 1/2 over 1 up 1/2. And it's on both sides. 2 squared, half of 4, 2 over 2 up 2. 3 squared, half of 9, 4 1/2. Nice. And there is my graph. Okay? And the rest of the directions say what? I graphed it, and then there's an and. Compare to its parent function. What's the parent function? Y equals what? X squared, which starts at 0, 0, goes over 1, up 1, over 2, up 4. So here is my parent function. Okay, everyone okay with that? All right, we've done this before, compared it to our parent function. So compare it. Compare and contrast. What's the same? Okay, the y equals 1/2 x squared is wider than its parent function. I'm just going to put PF. Are you guys okay with that? Its parent function. What else? Parent function. Okay. Where does it start at? Okay, they both start at the origin, right? They both go up. Good. Both open up. What else did they have the same thing of? Start at the origin. That's vertex right here. What? Good. They both have the same axis of symmetry. Good. Okay. Nice. So we said what they had the same of. We said what was the only thing different is 1/2 is wider than x squared. Okay, right? And then everything else is the same. They start at the origin, they both open up, and they both have the same axis of symmetry. Good. Everyone okay with that? This is just review, right? We've already done this. Next one. You guys do it. Don't look at me. Work. It's Tuesday, not Monday. Come on. Already be into school. Long. No. Close to it. And my maybe soon to be fiance, I don't know. I haven't decided if I'm going to say yes or not. Had a family, a death in the family, and he can't come down and visit me. You know, maybe soon to be. But he would have to move here. I'm not moving to Chicago. I have too much in my retirement here. I'm sure. I don't want to have to work till I'm 80 before I can retire. I know. I already am. Are you done? You're done, right? So you can come up here and do this for me. Are you in debate at all? Bless you. Okay, what is my vertex? Good. 0, 2. Nice. Okay. What is my line of symmetry? Because what's with the x? 0. Good. Axis of symmetry? Yes. Is the x coordinate of our vertex is the line of symmetry. In case you haven't figured that one out yet. Okay. So if I go over 1, how far am I going to go up? Oh, I'm going to go down. Good. Down how far? Oh, down. Okay. So if I go over 1, how far am I going to go down? How'd you get 2? How do we get that we go down 2? How far do we normally go? Over 1, up what? 1 squared. Then I'm going to multiply by what? 2. And 1 squared is 1, and 1 times 2 is, I'm going to go start at 0, go over 1, down 2. That's my line of symmetry. If I go over 2, how far am I going to go down? 8. Very good. 4 times 2, which is 8. Good. Over 2, 4, 6, 8. And then I'm going to draw in my, oops. Okay, great. There's my parent function still is here. Okay, so there's my parent function, and there's my graph. So, compare and contrast. Someone tell me something is there anything that's the same? Let's start with the same. This axis of symmetry is the same. Good. Right? Sorry, my writing is really bad. That's why I try to type most stuff. I try. Have you seen your writing? Okay. What's different? Okay, goes down. Okay, it opens down instead of up. Definitely spelled instead wrong. Okay. What about the vertex? Okay, so how can we say that? We want to use the word shift is what they're going to use. Good. Nice. The vertex. Oops. Oh my goodness. Shifts up by 2 units. Good. There's one more thing we need to talk about. Is it narrower or wider than the parent function? Narrower. Good. Okay. It's narrower than its parent function. Good. Okay. I missed the end. Sorry. Yeah. Not written very good, is it? Yes, honey. Okay, what? The plus 2 is the 2, right? Because it's on the outside. Remember, these normally have a parenthesis, and what's inside the parenthesis is our x coordinate. Is there with the squared, right? There's nothing inside the parentheses, so my x is going to be 0. And what's outside the parenthesis by itself is my y coordinate. Does that help? Okay. Anybody else? Question? This one? The graph opens down instead of up. Yes, it says opens. It's OPENS. Yes. The vertex shifts up by 2 units. Shifts. Instead of. It's instead of. Okay, we good? Oh, no, there's still people writing. SHIF. Oh, I forgot the T. Shifts. At least I didn't remember the T and forget the F, right? Oh, I know. Good, huh? Okay. Everyone good? LaShonda, are we ready, honey? Okay. All right. So what if we wanted to graph this function? vertex form? No. Is it in intercept form? No, it's not in either form. So this is standard form, and we need to learn how to graph in standard form. Because there will be some equations that we can't put in either one of yet. Put in either one of those forms, okay? So we're going to learn how to graph this. This is all, I just put this up here so we could look at it and be perplexed for a minute. You're welcome. So now on the next screen, we're going to learn how to graph this, and then we're going to graph it. So if you write it down, the slide, 2 slides later, it's the exact same slide. Hello, Petty, problem? Over there. I forgot there was one on my desk. Okay, so let's talk about the properties of the graph of ax squared plus bx plus c. Oh, I forgot to put spaces in there. If he has a ring and he's going to ask me. And I'm not sure I'm going to say yes. He annoys me. Okay, so it opens up if A is, it opens up if A is greater than 0 and opens down if A is less than 0. So just like on the other ones, if A is positive, it's going to open up. If A is negative, it's going to open down. And A is always the number in front of x squared. No. No. Okay. Okay, it's narrower than the parent function if what? Can anyone guess if when it's narrower? Bigger number than what? When A is, the absolute value of A is greater than 1. Right? So if A is greater than 1, then it's narrower than the parent function. Okay? So 2, 3, blah, 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 right? So on and so forth. Wider would be when? Yeah, when the absolute value is smaller than 1, which means when it's a fraction. Okay? And technically it's not only a fraction. Your fraction has to be less than 1. Okay? Because we all know about improper fractions, and those are greater than 1. Okay? Question so far, not too bad. This is almost exactly what we've already kind of talked about with the other forms. These are the same things. Okay? Here comes something different. Axis of symmetry. Actually, no, it's not different. My axis of symmetry is x equals minus b over 2a. So I'm going to take b, put it in, take a and put it in, figure it out. Okay? It's a little bit of algebra. Yes? Yes, there is. But we're not learning that yet. That will be tomorrow. I know, it was. So you already learned how to do it, right? So you could have went to the systems of equations and did that one. Okay. Oh, I guess we need to put the first thing. My vertex has the coordinate of this. We already know this. Our vertex, our axis of symmetry goes through the vertex at my x coordinate, right? So this shouldn't be any different. Sorry, I keep touching it. It fades in and out, right? You mean you can't read it when it's fading in and out? Nothing different. The only thing different is how we find our axis of symmetry. Okay, that's it. And then we find our y-coordinate of the vertex by doing what? Anybody want to guess? You take your x, right? Plug it into the equation and solve for y. Really? Y equals? Okay. And the last thing we're going to talk about is my y-intercept. This one actually has a y-intercept that will be on the graph of your parabola all the time. Yes, honey? Well, the y-coordinate, how you find it, right? You take your x-coordinate, plug it into the equation, and solve for y. Just like we did in intercept form. The vertex is always on the axis of symmetry, yes. It's okay. My y-intercept is C. Whatever C is, that's my y-intercept. Oh, okay. Okay. Everyone okay with this? Got it all down? I want to go until. Put your phone away. It's not, it's water. It's water. Next time I see your phone, I'm taking it. Especially when you're texting. Really? Yeah, except right then when I sprayed you, you were wet. Uh-huh. Okay, so let's go back to the original problem and graph it. Okay. So is it going to open up or down? Oh, that one you can't see. It opens up because my A is positive. Okay? Is it going to be narrower or wider than the parent function? Narrower because A is greater than 1. Okay? Okay. Narrower than PF. What does PF stand for? Very good. Okay. And then we want to find my my axis of symmetry, right? And to do that, it's x equals negative b over 2a. So what does b equal? Anybody know what b is? 6. How do we get b to be 6? Because it is very good. Because standard form says ax squared plus bx plus c. So b is the number with the x. A is what? 2. It's the number with the x squared. Okay, take those numbers, I plug it in. Okay? So I get negative b over 2 times a, which is 2. So that's negative 6 fourths, or negative 3 halves. Is that correct? 1 1/2? Yeah. 6 4 6 plus 1 1/2. Okay, so my axis of symmetry is -1 and a half. X equals -3/2. Okay? So I know on my vertex, my x-coordinate is -3/2. Yes? Yes, honey. It's not, honey. It's actually halfway between 1 and 2. You okay with that? Okay. It might be a little hard to see, sorry. Okay. -3/2. Okay. How do I find the y coordinate? The y coordinate is not C. I plug -3/2 into this equation. So I get y equals 2 times -3/2 plus 6 times -3/2. Oh, this should be 3/2 squared, sorry. Plus 3. Order of operations says I do what first? Exponents. Yeah, parentheses. There's no parentheses, right? So I'm going to do exponents. 2 times, what's -3/2 squared? Ooh. What is -3/2 squared? -9/2 squared. Oh, sorry, 3/2 squared. My bad. 3/2 squared. You got 3/2 squared is 3. Okay. 3/2 squared is the same as saying 3 squared over 2 squared, which is what? 9/4. Which should probably be 2.25. Okay. So 6 times -3/2. Anybody? It's not -18. It's -9 because it's -18/2, which is -9. All right? Now we need to do the other fraction multiplication. 2 times 9/4 is what? -18/4. 9/2, thank you. Equals 9/2, which is 4.5, yes. -9. Oh, but I don't want to put -9 because I have a half. I want to put -18/2. Isn't that 9? Okay, plus 6/2. Can I add? Can I add fractions without the same denominator? No, so I just made them all the same denominator. This is still 9, right? 18/2 is what? 9. Right, just took 9 times 2 and put a 2 underneath it. And 3 is 6/2. So what does that give me? -9 minus 18 plus 6 is what? -15? -3. 6 minus 18 is what? -9. And -9 plus 6 is -3/2. Well, you shouldn't have a lot of fractions. I tried not to give you a lot on your homework. Okay? Just so you guys know. I tried. So my y-coordinate is -3 halves. Ended up being the same, which is -1.5. A different color there. It's right there. Okay? And then what is my y-intercept? Which is what? 3. My y-intercept is C, which is 3. So I know on my y-axis I'm going to go through 3. I also know that it's symmetric. So where's the point on the other side going to be at? It's 1.5 from the line, so I'm going 1.5. It'll be right there. And there it is. Okay. Because of this part. All I did is go through the things that we wrote down on the last page. Opens up if A is greater than 0 or positive, right? It's narrower if A is greater than 1. Axis of symmetry is this equation right here. So we just plugged in the numbers and got my axis of symmetry. And that's also my x-coordinate of my vertex. And then that's where it kind of got complicated. Plug this in to here because we have fractions. And then we got our point here. Okay, we're going to do it again. Don't worry. Right here? Yeah, 2a. So a was 2, so that's 2 times 2. Right? Yes. Oh, I thought that was your hand. Everyone okay? We're going to do another one. Don't worry. Don't panic yet. I'm not going to say, okay, go and do it. Because you guys are all looking at me like, I don't know what to do. That's okay. Let's try another one. Yes. No. When I'm done. No. Okay. So the first thing we need to know is it opens up or down. Opens down. Why does it open down, Carla? Why is it open down? Yeah, the x squared is negative, so it's going to open down. Good. Is it narrower or wider? It's neither. Why? Because it's exactly 1. The absolute value of 1 is 1, right? So if it's the same as the parent function, which is 1, my parent function says y equals x squared, which has a what out in front of it? 1. So it's going to be the same width. Okay? What means, honey? Y equals, oh, f of x, yeah, f of x is just a function. So why would we call f of x instead of y? What if I graphed things on the same graph and I didn't want to write out that equation? I could call one f of x and I could call the next one g of x, or I could call it h of x, or I could use all. So you could put 3 or 4 graphs on the same thing just by naming them f of x, g of x, h of x, different things without having to write the equation on there. Okay? Because f means function. And this is a function, so that's why they started with f's. Okay? So where's my axis of symmetry at? What do I need to know to find my axis of symmetry? Negative b over 2a, right? So I need to know what b is. What is b? So we're in the form y equals ax squared plus bx plus c. So b is 4. A is no, -1. Good. I'm going to plug it in and find out what my axis of symmetry is. Minus 4 over 2 times negative 1. Negative 2, jumping ahead. Negative 4 over negative 2 is 2. My axis of symmetry is 2. Because what is A? Right, the number with x squared is 1. Yeah? Okay. Now, how do I find my vertex? We know that the x-coordinate is 2. We need to find the y-coordinate. How do I find that? Plug it into the equation. Good. So I get negative. Y is going to equal negative x squared, negative 2 squared, plus 4 times minus 3. What's negative 2 squared? No. Negative 4. Thank you. Because the squared is not touching the negative sign, it's only touching the 2. We're only squaring x. What is x? We're not squaring the negative. Okay, oh, sorry, we're not squaring. Yeah, we're not squaring the negative. We're only squaring what? The x. And x is 2. Yes? Okay, 4 times 2 minus 3. So negative 4 plus 8 minus 3. Because this is negative 4. Negative 4 plus 8 is 4. And 4 minus 3 is? Are you okay with that? Okay. So my vertex is at 2, 1. There's my vertex. The only other thing I need to graph this now is my y-intercept, which is what? Negative 3. Good. It's 2 away, so it's going to be 2 away. There we go. My curves are not very curvy. I know. Sorry. Can't make it look better. A little bit better, Carla? You see what this one's less confusing because there's no fractions, right? What? Okay, so we know what my axis of symmetry is, right? I drew it in. Right here, we found it out what the axis of symmetry is. Axis of symmetry is 2. Yep, I plug it into this equation, and I get 2. So I drew my axis of symmetry. That's also my x-coordinate and my vertex, right? So then I plug that into my equation, got my y-coordinate, which is my vertex. You got that one okay? So then I'm going to start there. And then the other point that I know for sure is on the graph is my y-intercept. And my y-intercept is C, right? So I went down negative 3 on my y-axis. And this is a line of symmetry, which means there's got to be a matching point on the other side the same distance away, right? Right. I didn't go down 3, I went down 4, actually. From the origin, I went to negative 3. And this, from my line of symmetry, is 2 over, so I just went 2 over from my line of symmetry on the same line. Because it's got to be symmetrical. That's what symmetry means, right? Huh? Yeah, to find your y-intercept, you're going to start at 0. Y-intercept is just like graphing a line, right? Y equals mx plus b. Y-intercept goes on your y-axis. Okay? And then I make a curve that goes through those 3 points. Yes, no, maybe so? Okay, well, good. You're going to prove it to me. Yep. Prove it to me. So what things do we need to know? We need to know what it opens, right? If it's narrower or wider or the same. Okay? We need to know our axis of symmetry. We need to know our vertex. Oh, it's because I'm like, why can't I see what I'm writing? Vertex. And we need to know our y-intercept. Those are things you need to know. And you're going to use the characteristics to find all that stuff, or the properties that we discussed earlier. I need popsicle sticks so I can draw names out and make you come up and do it on the board. I think it's a great idea. Because then people who just sit there and stare at me like they don't know what they're doing will have a chance to come up here and do it. because there's a negative out here, so that was minus a minus, which made the 5a plus, and then we still have one more negative, so it would be, are you okay with that? Negative 7.5. Can we use decimals? Sure. Okay. So my axis of symmetry, 1, 2, 3, 4, 5, 6, 7.5. X equals 7.5, right? Oh, negative 7.5. So now I know negative 7.5. Now I need to put it into here. I'm going to get really ugly math here for a second. Okay? Negative 1/3 times, I want to go back to fraction for this, 15 halves squared. Woo! That's going to be ugly. Minus 5 times 15 halves plus 2. Negative 1/3 times 225 fourths. Yes. X squared is going to be wherever our vertex is, our axis of symmetry. And the vertex is always on the axis of symmetry. How come I did what? Because X, right? Oh, this should be negative. Sorry. It should be negative. Sorry. Thank you. Thank you. I know. Well, that's because on some of the reflective journals, people are like, you need to explain more. So, oh, and I'm not even talking into the mic, so no one's going to be able to hear these last couple things we've done. Doing so good. Okay. So mine plus 15 times 5, 30, 60, 75 halves plus 4 halves. That's 2, right? What's 4 halves? Where'd I get 2? Right here. Isn't 4 halves just another way to write 2? Okay. I'm probably going to switch it to some other number because this is really ugly up here. This is negative 225 over 12 plus, to get it to be a 12, we need a what? Multiply by 6? So 75 times 6. $1.50, 3, 450. Yeah, I'm making my denominator 12, because that gives me a 12 here. So I have to have the same denominator, which means I need a 12. So I'm going to multiply. How do I get 2 to a 12? Multiply by 6. Plus 24 twelfths. Oh, this is way ugly. If I would have known it was this ugly, we wouldn't have done it. Just so you guys know. Okay. So minus, someone have a calculator? You have one. Minus 225 plus 450. Nick. Yeah. He put the negative in there. And then plus 24. Gives us what? 249 twelfths? And 249 divided by 12 is what, honey? 20.75. I don't even think I can get that on my graph, even if I count by twos. Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There we go. No, you still have to graph. My y-intercept is what? Although it's definitely not going to fit on this graph. What's my y-intercept? 2. My y-intercept is 2, and I'm 1, 2, 3, 4, 5, 6, 7.5. 1, 2, 3, 4, 5, 6, 7. Sure, that's close enough. We knew it was going to be wider, right? Okay. I know, it is huge. So when you're doing your homework, I suggest that you don't put in your axes, right? until you know the rest of the stuff. Okay? Because then you can adjust your axes to where they need to be. Yes? Okay, great. We're going to talk about one other thing before we go. We're not going to do that. Okay. Maximum and minimums, which we kind of already know, but we really haven't officially introduced them. Okay? Yes, because if you notice on your last homework, they asked you to find the maximum and minimum. Okay? So, yeah, it is kind of important. If you guys keep wasting my tape, I'm going to hurt you. And winding it around and round in your fingertips. Uh-huh. Okay. So we know it's a minimum if A is positive. Okay? And we know it's a maximum if, can anyone guess? A is negative. Very good. Why is this? Well, if I'm graphing something, I have my vertex, and A is positive, I know it's going to open up. So this is what? My lowest point, which makes it a minimum. If A is negative, it opens down, which makes this point my highest point, so it is a maximum. How do I find said maximum? Find your axis of symmetry, plug it in, and the highest point, find your y value in the highest point. Okay? I would go over it, but we're kind of running out of a little bit of time. Okay? So I will tell you there's an example in your book. Okay? If you haven't noticed in your book on the problems, it says right next to the problems what example and what page that example is on. So, oh my gosh, you could flip back in your book and look at it. Okay, but it's half of what we've already been doing. We've kind of already done that. Okay. So here's online help if you need it. Let alone going to YouTube and putting graphing quadratic functions in standard form in there will give you tons of videos on how to do it. They don't know how to teach? I'm sorry. Plus, I did give you guys my phone number, so if you need help, you are allowed to call me before 10 o'clock. Yes. Because I go to sleep by 10. If I don't answer, I'm really asleep. So sometimes I go to sleep, it's like 7. But I did give you guys my phone number. Yes, honey. The videos that I post the videos on, and I have to post the last two. It is MC Campbell .wikispaces spaces.com. I can get on it here. It's not allowed for students, which is really but at home you can get on it, right? You can't get on YouTube here either. Okay? Okay, everyone good? Okay. And your homework is, oh, yeah, we did that. Here we go. 8 through 40 even, 19, 39, 44, 45, 46. your progress report. Some people actually did missing homework this weekend. Okay? Some people actually do homework that they're missing over a 5-day break. Imagine that.